Fran, Dan wants to know, what is quantum entanglement? Can we create it and how does it work? But you better tell us first actually what quantum is.
So quantum mechanics describes the physics of how very small things work. And it turns out that the physics of how very small things work is super weird and nothing like the physics of how everyday objects work. And one important point is that in quantum mechanics, nothing is decided until we measure it.
Can I just clarify, when you say really small stuff, how small is really small?
So the size of an atom or an electron or a proton, which are the particles that are in atoms.
Does that mean then if I could, with a microscope, start with something big and watch how it behaves and get smaller and smaller and smaller and see progressively smaller things, I would suddenly at some point see the behaviour switching and going into this quantum realm where things behave totally differently than bigger objects?
That's a very interesting question, whether you could do it gradually. No one quite knows how the transition from quantum to classical physics works. It's one of the really open mysteries because there isn't a microscope that can do that whole range.
Ah, so the quantum mechanics has thought of that and caught us out.
Yes, quantum mechanics is very good at doing that kind of little trick.
Niels Bohr said, if you're not baffled by it, you didn't understand it, didn't he? He's saying, look, I understand how it works, I understand the results I get, but I don't understand why I get.
That's absolutely right. Quantum mechanics is a set of rules that's very, very good at predicting the results of experiments. So you sort of have to go with it.
And just abandon all hope of actually understanding why. You just know it works.
We haven't abandoned all hope. There's a lot of scientists working on it.